Chapter 3. We're going to get into like some algebra stuff in Chapter 3. Some of it you've done before in solving for equations and stuff. We're starting just with really a section that's full of a lot of terms. So I'm going to say formulas and variables. So formulas and variables. And I'm not going to do Roman numerals. I'm just going to start by saying, all right, first thing we're going to look at is a variable. So the most common variable, we usually use the letter X. X is real common, Y, some others. But it could be a letter or symbol. A little bit later I'm going to start using Greek letters, especially for angles. Makes you look smart because you're using symbols that people don't recognize. But a letter or symbol that represents a quantity. That can, if you have that word variable, you kind of have what word inside variable? Vary. Now, there's several of them you could have said in there, but that can change. So a variable has to be something that its value, its amount, its worth could change. And a real common example that I use at least when I have to teach this is, let's say you have the equation area equals pi r squared. So you're talking about a circle, in the area of a circle. Well, is A a variable? Yep, it represents a quantity. It represents the area of a circle. Could the area of a circle change? Yep, big circle versus small circle. Okay, what about pi? Variable, not a variable? Nope, because it can't change. It represents this number 3.14159, etc., etc., etc. It doesn't ever change. But the other variable in there is the r, because r can change. The number 2, that doesn't change either. That's a constant. So variables. But I'm probably on a quiz, on a test, going to give you something with a pi in it or something like that to see if you pick it. Instead, pi isn't a variable. Do you remember the name for something like pi? Go for it. Starts with a C. Nice, constant. Constant. So a constant is going to be something that doesn't change. So something that doesn't change. So you could talk about like a number. I'll maybe say example. So you could do like numbers like 2 or 4 or 153. But also I'm going to put in like things like pi. And you'll learn more of those like constants, special numbers that you use in math and science as you go on and do more stuff. We good so far? An equation doesn't show up in our notes here, so I wouldn't busily write that down. But an equation has to have what? Numbers. Typically. I guess it doesn't always have to, but it has to have an equals. Equation kind of has that word equal as part of it, like the equal root. So it has an equals and something on both sides. A formula, the next thing we have in our notes, is a special type of equation. A formula is going to be an equation, so it has to have an equal sign in it. It has to have something on both sides of the equals. But one side has to be solved for a variable. So I'm going to say formula equals an equation. I'm just going to do EQN for equation in the form of, so it's an equation that looks like this. And I'm going to say one variable. So one variable equals something. So you could have, I guess I could write examples. You could do something like that, area equals pi r squared. That's a formula for the area of a circle. But you could also just have x equals, somebody give me a number?
2. 12. 148.
12.248. So everybody wins, but 12.248 is a formula. X equals 12.12. Yeah, I'm smart. Okay, x equals 12.248. That's a formula. It tells you what x is. It has one variable by itself equals something. if we're taking and putting numbers into a formula, so if you go back up to that a equals pi r squared, if we wanted to find the area of a circle, we'd put in the radius of the circle. So if we knew the radius was 4, we'd put a 4 in right there. Do you guys know the official math term for putting a number in for a variable? Related to sports?
Exchange?
Nice. Substitution. So substitution. You could write it if you want to. You might want to write it. Seems like we struggle with that a little bit. But substitution. Substitution is going to be when you replace variables with numbers. So you replace variables. Or it could be singular. It could just be one variable with numbers. So sometimes you'll get the question that says, substitute 4 in for x and 17 in for y or something like that. Example, I'm going to say given d equals s times t. Do you guys recognize that thing?
Nope.
Distance equals speed times time. Yep, good. Distance equals speed times time. I'm going to say we have an airplane, a Boeing 747, traveling 4 hours. So we'll just say the speed, I'm going to keep my notes a little bit shorter. So speed equals 604 miles an hour. So 604 mi over h for 4 hours. And I know some people really don't like showing their work, but you're going to find it just makes the most sense if you just do d equals s times t. And then we take that 604 and what do we do with it?
Times 4.
Yep. But I was trying to get you to zoom. If you take this and put it in here, so we have 604 miles per hour. Then we take our 4 hours, and that's our time. So we do times 4. And a lot of people saw right away, it's like, okay, you just 604 times 4. But one advantage of perhaps doing it this way is once I get my number of 2,416, what happens to my units? I have miles per hour times hours. Could even look at it as though it's hours over 1. Would you agree? I end up with hours in the numerator and hours in the denominator, so they can cancel, leaving us with miles. Which makes sense for a distance. If you're talking about how far does the plane go, miles would be the only units in that problem that would make sense. Fair enough? Mm-hmm.